give us the most time inside the totality region. We can slip the airplane. That'll give us some more bank angle, which lets our cameras see a little bit higher. So all of those kinds of things were what went into from a pilot standpoint, planning this out.
All right, you guys ready to turn in again for a partial?
I think it makes us proud of what we do, and that we're able to share it with everybody around the world in this case, due to the modifications to the airplane we made. That's what we do.
How you doing, Cope?
Great. Wow. I can't wait to see what that G3 is going to show us today.
That was amazing, and it's going to be an incredible view, the first view of the solar eclipse as it's literally crossing into the United States.
So basically it is off the west coast right now, so it's getting a view of the eclipse before we even get a view from land.
Right,
of that partial eclipse.
And that G3, it's one of a fleet of NASA aircraft and observation platforms that we have. We've got, as we mentioned earlier, satellites, both ours and some of our partner agencies, aircraft, the balloons that we've got, and we'll be telling you more about that in our 1 p.m. Broadcast as well. But we've got you covered here. It's in terms of, eclipse, not only looking at it from the ground, looking at it from the sky, looking at it even from space. I don't know if we can get a little preview to that.
Great, and you know what I just heard? We've got the Salem, Oregon eclipse starting.
Wonderful.
This is the partial transit, and we're going to the G3 now to see what they
Live
can
to the
see.
G3.
We've got an exclusive feed as they fly over the Pacific Ocean, and Kevin Rohr from NASA's Armstrong Flight Research Center is standing by. Do we have Kevin?
Okay.
All right, he's going to be up soon.
But you can see, and we actually have a monitor here on set in Charleston, so we can actually see what they're seeing live, and you can see the transit beginning as the moon is just starting to eclipse the sun. Isn't that an incredible image, Karen?
No, it's beautiful. And so just to be clear, what you see on the screen right now, right, is that partial transit. The partial transit can take, the partial eclipse can take, up to 3 hours, a little bit longer in any one location. Whereas the total eclipse, that's only about a minute and a half, 2 minutes.
Right. A lot of people talk about the totality, only lasting maybe at most 2 minutes or so. But sometimes people don't realize that in terms of the entire eclipse, from the very beginning of when the moon starts to cross over the sun's surface till the end is actually much longer.
Yep.
Okay.
Great. So let's talk a little bit more about these eclipses, because I want to tell you one of the things that I think is one of the cool things about total solar eclipses. We're the only planet in the entire solar system that can see them.
The only one.
The only one. Earth is the only planet where the moon appears to be the same size in the sky as the sun. And that's really just a great cosmic coincidence.
That's right, Karen. The sun, believe it or not, is about 400 times wider than the moon, but it's also about 400 times farther away. Now that geometry means that when they line up just right, as they are today, the moon blocks the sun's entire surface, creating a total solar eclipse. Let's take a moment to learn more about that geometry.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. it has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
Wow, that was amazing. So now we've got a live shot from that G3 aircraft looking out the window as the eclipse begins.
We're going to be seeing the eclipse live from this G3. It's 35,000 feet up in the air.
Over the Pacific Ocean as the eclipse begins. Very interesting to see how they had to sort of retrofit it with the special glass to get the best viewing possible. And I'm sure it's an exciting moment up there. I can only imagine what the folks inside the G3 are feeling right now.
Great, and coming up we will have some live interviews from the G3. And now we are once again looking at the eclipse from Salem, Oregon. So to all the people who are out there in Oregon, this is what they are getting to see right now, that first little glimpse of the moon. It almost looks like a bite out of a cookie, right? A little first glimpse of the moon passing in front of the sun. Now Salem is in the path of totality, so they will have a chance to see the full eclipse.
And they've got great weather from what I can tell, and certainly a good shot from this telescope there on the ground looking at the eclipse. It's amazing. And just a reminder for folks, we can't say it enough, stress it enough, the safety aspect. If you are anywhere, whether you're in the path of totality or not, you've got to have those glasses, even if you're looking at a partial eclipse, even if it's cloudy.